Hey there, and welcome back to Red Spark's crypto blog for all your crypto and Cardano news and analysis. Today we will be looking at Plu-Ts, a programming language that lets you write Cardano smart contracts in effectively TypeScript and then compiles it down into untyped Plu-Ts core UPLC and submits it to the Cardano blockchain. And yes, I did say TypeScript. JavaScript's a younger and cooler brother, and also, to be fair, slightly nerdy as it enforces a lot of rules and regulations on you about data types and so on. But let's not dwell on that. Now, what I'm going to be doing in this video is taking you through the Hello World tutorial, which is also a great introduction to how smart contracts work on Cardano. So even if you're not planning on coding in TypeScript, but you want to understand better how smart contracts work on Cardano, then this will be a good video to watch. Okay, without further ado, let's jump right in. Okay, so here I am on the main homepage, Plu-Ts.harmonicslab.tech. This is definitely the page to start off on. If you just randomly Google Plu-Ts and Harmonics or Plu-Ts and Cardano, you might end up on the GitHub repo or the documentation here. However, neither of these actually link to the Hello World contract that we're going to be looking at today. So definitely start from this page here. And then you see there's various links down here, but we're going to click right on the button up here, write a smart contract in 5 minutes. Okay, so the only two prerequisites to using Plu-Ts is to have npm installed and to have git installed. npm, for those that don't know, comes packaged with Node.js, and Node.js itself is the de facto sort of JavaScript server that's used on the web. And you can get Node.js from this link up here and install it for your operating system. So this is a new sort of user account that I'm using, so I'm going to have to install it myself. So I'm going to select Windows here and 64-bit, and then that will get downloaded. And then for Git, I'm going to go to the page up here, git-scm.com. I'm going to just download Git for Windows 64-bit over here. So I'm going to do that and then get back to you. Okay, so I just finished installing those two items. When you install Node.js, it will ask you if you want to install additional tools, which you can untick for this. That's just really installing Chocolatey, which we're not going to need. And then when you're installing Git, the only thing I did change from the default settings was whether or not to use Vim as my default editor. No offense if you're a fan of Vim, but I personally think you have to be a masochist to use it. So I chose VS Code for that option, and as I said, stuck to the default options for the rest of it. And now I can confirm that I have got both of those installed properly in PowerShell. I'm using the latest PowerShell version 7 here, which I downloaded, but ordinary PowerShell in Windows is completely fine too. So if I just type in npm-v, npm space -v for version, that will give me the version there, and I'll do the same for git-v, and I can see that I've got both of those installed. So make sure that you can do that before proceeding. Okay, so the next step here is to run these commands. What this will be doing is downloading the Plu-Ts GitHub library there, or repository, moving the Hello World tutorial out into its own folder, going into that folder, and then removing the original download. So we're just going to copy that entire bunch of text, and we're going to paste that into our window. PowerShell is telling me, do I want to copy or paste in multiple lines here, which I do. So I've done all of that. I press enter on that last line, and let's just do an ls to list the directory and just see where we are. So we're now in this Hello Plu-Ts folder within my main Plu-Ts folder that I had set up already, and these are the sub items in that folder. Okay, let's now proceed to the next step, which is to compile the files that I just downloaded using npm. So I will paste that into the terminal there, and wait for that to finish. Whilst that's finishing, let's have a quick look through the rest of the file here. So we're going to end up with a source folder, and in there's going to be a contract.ts folder. So let's have a look at the compilation. Okay, that's now finished. So let's do ls again. So now I'm going to actually switch over to VS Code, and we're going to have a look at the folder that's being referenced here. Actually, before we begin, I thought it'd be helpful to give you a quick overview of how transactions and smart contracts work on Cardano. So if you imagine you're using your favorite DEX and you want to transfer one token for another, the front end of your DEX will be the transaction builder. It will convert your instruction into a transaction that the Cardano blockchain can understand, and then that transaction would get submitted to a stake pool, and that stake pool will take your instruction, but before it carries out your instruction to move funds around, it has to check whether what you're asking it to do is actually allowed. Now, should it be doing what you're asking it to do? It's not going to know, obviously, by itself. What it does is it refers to the script or the smart contract, aka the validator that you have referenced in the transaction. And it's saying to the validator, here you go, here is a transaction that somebody wants to carry out. Can you tell me whether or not I should process this? And so the on-chain portion of this entire sort of smart contract process, the on-chain script, is simply evaluating your transaction and giving a yay or a nay, yes or a no, whether or not you're allowed to do that. And that's why that part of it is stored on chain, because that is the logic that you don't want anyone to tamper with. Whereas the transaction building side, that can be anybody can create any transaction. It doesn't matter. You might be thinking, well, what if somebody creates a fake transaction and says they want to move money out of my account? Well, that's why the validator is so important. The validator will be checking, in that case, it'll be checking the credentials and the signatures to make sure only authorized people are constructing the transaction that you're wanting to do. So that's why the validator is so important. And that's why a smart contract on Cardano can sometimes be called a validator. It's just checking the various information the transaction is giving it, and it's just simply saying yes or no. And then that gets returned to the stake pool, and if the stake pool gets a yes, it'll carry out the transaction. If it gets a no, it won't carry out the transaction. Okay, so now that we've got that sort of basic overview in our heads, let's go and take a look at the actual code. Okay, so here we are in VS Code. I've got the Hello Plu-Ts folder open there. And in there is this source folder here, which contains everything you need to compile your validation script, or aka smart contract. And that contract itself is stored in this file, contract.ts, and it's specifically this function here, which we'll go through in a second. But this is actually your actual smart contract. And the process that Plu-Ts does is it converts this into the native sort of format that the Cardano blockchain uses. And then that gets submitted and sent to be stored on chain, on the Cardano blockchain. That native format is not Haskell, by the way. Haskell is just another language, just like JavaScript. So if you were learning how to code this using Haskell, you'd be learning how to program something in Haskell, and then that Haskell gets converted into the native format that Cardano uses, and that native format is then submitted to the blockchain. So we're just using JavaScript here, and there are other compilers using other languages. They're all on an equal footing. They're all just compiling down to the same type of native code that the blockchain itself uses. Okay. So we're going to start by looking at the index.ts file. This is the file that will be run by JavaScript when we try and compile this. And you'll see that it's just bringing in the script object from the main contract file. And after it does that, it then just prints out that it got compiled successfully. And for good measure, it's then giving us a printout of the hash of this script. I won't go into hashes. If you're not familiar with hashes, there is an article on my blog post. But hashes are a key part of how cryptocurrencies work. So let's take a look at this script function. What is the script function doing? So let's go into the contract file, and we see down here in the utilities section that there is a script function. But if we follow that back, what's happening is this make validator function is taking our smart contract, which we defined up here, and I'll go through that in a second. But it's taking our logic up here, running it through this function, which is basically turning it into a format that's ready for validation, then, or ready for compilation, I should say. Then it's actually being compiled by this function here. So this is now compiling it. And then that is what's then returned by the script function. So note that at this stage, we haven't actually submitted anything to the blockchain. This is all just happening on our computer. And not that we've even done anything yet. I haven't actually run this code yet, but I will do later on. So now let's take a look at the smart contract logic. The smart contract that's going to be stored on chain is saying, I need these three inputs. I need to be given a my datum, a my redeemer, and a PS script context. The first two is under our control. We can define that. So I keep hovering over it, but this my datum is actually defined in this index.ts file here, and in this case is just an integer number, and the my redeemer is defined over here, and it's just a struct that allows for two input variables there. So they're two very simple data objects or data carriers. Let's go back to the contract there. And then the last one is more specific to Plu-Ts or to Cardano, so it's a little bit more additional information. But those are the three types of information smart contract will bring in or consider by default. And then in this case, it's not actually doing much of consideration. It's taking them in over here, but it says whatever they are, I'm not going to look at them. I'm not going to really care about them. I'm just going to return true. So whatever transaction you are asking me, whether or not you're allowed to do, I'm just going to give you the thumbs up no matter what happens. I'm going to ignore these critical elements that you're giving to me. So obviously it's not a great smart contract. It's not a great policeman. It's always going to let you do whatever you want to do. And so if there was any assets that were tagged to this smart contract, so if you had some ADA that was tagged and under the control of this smart contract, then anybody could then transfer those assets out of this smart contract, because this smart contract is always giving you a thumbs up to everything. So we're going to look at how to modify that in just a second. But first, let's see a compilation in action. So here I am in my terminal, and I'm going to type in npm run start, which is the standard way of compiling and running any JavaScript code. And there you see it's running through the code, and it says validator compile successfully. And there we have the CBOR hex. What is a CBOR hex? Now, it's actually a detail you don't really need to know about, but I will go into some nerdy detail here. A CBOR hex effectively is your script address in compressed format. So CBOR itself is a compression method. You might be familiar with zip files, for example. That's just one example of a compression algorithm. CBOR is another. And which compression method you use depends on your use case. But it's zipping up something effectively. What is it zipping up? Well, your address. Zipping up your address. Apparently it zips you up twice. Again, another nerdy bit of detail that you don't need to know, but I was browsing this random post here on Stack Exchange, and this bit made me chuckle. Don't ask me why Plu-Ts core scripts are wrapped twice in CBOR and then unwrapped once to calculate the address. Some smart guys somewhere must have seen a good reason. So that's what's happening behind the scenes. Anyway, we don't need to know any of that. All we care about is the fact that this is a compressed form of our script address. A final bit of nerdy detail I'll throw in is that a script address is really no different from any other address in Cardano. It's generated by taking your script file, hashing it, and that hash function results in a a point in the Cardano address space. So what that means is if you change even one character of your script, maybe you put comment in with your name in it or something, it's going to result in a different script address pointing to a different point in the Cardano sort of address space. That's all I'll say on that for now. I might do another video on explaining the fundamentals of Cardano and how smart contracts work on Cardano. But I don't want to say too much now in case I get my facts wrong. Okay, before we get into the second half of the Plu-Ts tutorial, I thought I'd just give an overview of what we will be doing. So there's going to be two halves to this. One is deploying the actual smart contract once we've smartened it up. And the other is then using that contract. So specifically, we are going to first get some test ADA and put that in a test wallet. That's just an easy thing to do using a website. And then we're going to add better validator logic to our contract so that it doesn't just approve every transaction that comes its way. And then the next step is probably the most complicated step. We're going to write a separate bit of code which will construct our transaction. And that transaction will basically take our smart contract, fund it using our test ADA, and also tell the contract our public signature so that it can only be retrieved later by us. We'll see that as we go through what exactly I'm talking about there and how that works. But essentially, we're going to be submitting our smart contract to the blockchain, having it funded with our test data, and the smart contract will know that it came from us. That's the whole setup of the smart contract. So you now have a smart contract set up with some funds. Then we want to actually try and use this smart contract as an ordinary person. So we're going to build a separate transaction that will send a request for 10 ADA and a message, hello Plu-Ts, which is part of the validator logic that we'll look at. But essentially, if that request, that transaction that was constructed was coming from us and it had the right message, in this case, hello Plu-Ts, then it will give us 10 ADA. That is the end goal here. And that building a transaction in that bottom half that you see there, that is typically what your DEX, for example, would do. So when you're interacting with a website, the website of your DEX or any other Cardano dApp, they would be in charge of constructing that transaction code, or that code for that transaction. That is what's known as off-chain code. So you might hear the term off-chain and on-chain. On-chain is step 2 of that top half of the deploying the smart contract. The actual smart contract is hashed up and put on-chain, cannot be changed. That is on-chain logic. Off-chain is anything you code up that is not stored on-chain. So step 3 of deploying the smart contract on this page and step 1 of retrieving ADA from the contract, they are both examples of off-chain code that we will be writing. Okay, let's get into it. Okay, so the first thing we want to do is get some Cardano testnet ADA. So this is down here a bit further on in the documentation, but I would suggest doing this first. So let's just click on that. And what we want to do is, let's go back and read that properly, just be sure to select the pre-prod testnet. So what I'm going to do is select pre-prod there. I want to receive test ADA. And then I'm going to give it an address that they can send test ADA to. I do have a test address somewhere. In case you're wondering how to create a test address, because you might only be used to having a regular Cardano address, then pretty much every wallet should allow you to switch to test mode or to the test network. And then every wallet should allow you to create an address on the test network. I'll see if I can find a screenshot that I can share with you on where that would occur on my wallet, which is Eternal. Okay, so here I am in the wallet that I use, which is Eternal, and you'll see down here there was this option. It was previously on main network, up here, the Cardano main network. I changed it to use pre-production testnet, and then I can now add a wallet, to create a new wallet address here, and that will basically be exactly the same thing about getting a seed phrase, 24 word seed phrase, and all that stuff. But it'll basically be running on the test network, which has its own test ADA that you can request. Okay, next we want to update our contract itself, update the validator logic, and that essentially means replacing our contract code or updating it to what you're seeing here. So let's go through this. The validator logic we want to implement is only carry out the request in the transaction that you receive if the person who signed that transaction is also the same person who owns the testnet ADA. So that requires checking public key hashes with one another, and that the person requesting it has also sent a message, and that message specifically needs to be hello Plu-Ts. If both those conditions are met, then it's going to return a true. So that's what's happening in this code here. The return is simply evaluating these two things. So if this results in a true, the first half, and that results in a true, then the whole thing overall is a true, and that's what gets returned. The is being polite is defined up here, and it's basically taking the message that was received and checking that it equals hello Plu-Ts. And then the second one here is checking the signatures of the transaction, and checking that it matches the owner of the ADA. And we'll talk about this in a second, but that's what's happening here. Okay, so here we are in VS Code, and I just wanted to compare and contrast. This is the updated contract of ours that we were just looking at, and up here is what we previously had in our first version, which I've marked as _old. I just want to compare and contrast the two to see the differences and the changes we've made. So I'm not a TypeScript expert, but I think what's going on in both of these, if I understand the syntax, is that up here the data types are being defined for these three input parameters. So this is the actual function. Here are the input parameters, and this funny sign simply says, it's basically shorthand for function, really. And so down here, up here was simply returning true and ignoring the input parameters. And down here we are doing something with the input parameters. Okay, so up here we are defining different, I hate this pop-up thing. Okay, I'm going to hover over here. Up here we are defining different data types than we did the first time round. The first two, myDatum and myRedeemer, it is completely up to us what data types they are for those first two parameters. So in this case, for our particular use case, myDatum, which is the piece of data we want to track from across transactions, is the public key hash. So that's the piece of data that is going to be myDatum. That's what we're going to track. That's kind of the equivalent, I suppose, of long-term memory in Cardano. So Cardano doesn't have a global state, but what it does have is this ability to pass data from one transaction to the other. And the second parameter, this message here, is of type byte string, which is essentially just text. And the second parameter, also known as the redeemer, that is just any piece of data or input that is being brought into the transaction for that one transaction. So we see both the datum and the redeemer, so datum, redeemer, and the script context, which I think is extracted. So this is of type, so the input parameter is of type script context, a bit of a mouthful, but I think this is derived from a much bigger variable, the entire sort of UTXO reference, which we'll look at later. Don't worry too much about that. But I think it's extracted from that. But anyway, so this contract takes in three parameters: a datum, which is the owner of the prior UTXO, the message, which is the message to be used in this transaction, and the script context. Okay, the message is evaluated, which is a byte string, is evaluated to does it equal hello Plu-Ts or not. If it does, it returns a true. And the script context, so that's the CTX over here, that is used, and from the script context we extract the signatures of all the people that signed this particular transaction. So again, imagine this is a contract, this is what's on chain, this is the engine that's going to be processing whatever transactions are sent to it, and it's expecting to get the script context, and which is essentially about the transaction, and it's going to extract the people that signed the transaction that it's being asked to approve, and it's going to match that up with the datum that was also passed in, and that datum has to at least one of the signatures, so that's where the sum comes in, at least one of the signatures has to be the signature of the owner. Now, if you didn't fully follow that, don't worry. I think when we go further down the tutorial, some of what I just said there will make a bit more sense. The last thing I actually want to point out is the top of the contract TS file. We've just extended it to include this p pub key hash and this BS, which wasn't mentioned in the tutorial. So if you're just following along the tutorial, you might miss out. But make sure you put those two into the import statement. Okay, so after updating the contract, we can run npm run start to compile it again, which I did over here. And you see there's the CBOR hex over there. Going further down, the next step is deploying the contract. So we have created the contract that we want to put on chain, the on-chain code. We now need code that will take that and take the on-chain code and put it on chain. So that's where this step comes in, because the on-chain code isn't going to just magically move itself on chain. We have to write off-chain code to help the on-chain code get on chain. And for that, we need to use a third-party tool called Koios, which I actually haven't heard of before, so it's new to me. But I'm just going to go along and follow these steps and then get back to you. Okay, I'm back. So it was fairly straightforward. I ran npm install and installed Koios Plu-Ts. Then I ran this one as well. Then I made a new folder, a subfolder called off-chain within the source directory. And that contained, it doesn't say it in here, but it should basically contain a file called koios.ts for TypeScript. And that koios.ts file should contain this code. So make sure you do that. Okay, so that gets us through all that sort of setup process and down to here. Actually, I just realized that for part of this video, I'd been referring to the wrong version of the Hello World tutorial. So this is a right version accessible through this link, through the main website. I somehow got myself onto the GitHub repo and was looking at it on there. A key difference between the two is that on the official sort of website version, there helpfully is a name of each file. So there's a name of that file, whereas in the GitHub version, you don't have that. Okay, so I'm going to speed things up a little bit here as this video is taking a bit longer than I anticipated. But certainly having these file names will help a lot with working out what goes where. In terms of what this file here does, so previously we brought in the Koios provider in a separate file. We're just mainly really doing an import and then exposing that for other files to use. And then in this file, we see down here, we make use of that to build what we call a TX builder. So essentially, we're going to be using Koios we are using Koios to give us a object that will allow us to publish our script on chain. And so this file is all about making use of Koios to get that transaction builder object that we're going to need. And you know, it refers to Koios down here when it does that. And then down here it says get some funds, but we actually did this step earlier. If you recall, I showed you how to set up a test or pre-prod wallet in, I think I used Eternal when I did it. In fact, there's my pre-prod wallet there. And then you go to this page, and then the link is on the tutorial. You go to this page, you select pre-prod testnet, type in your address, and you then get some free testnet ADA. So that's me requesting, so that should hopefully arrive in a couple of minutes. Okay, so now that we have some funds, and this is just telling you how to do it programmatically if you needed to, but you can just do it manually like I just did. Okay, right, build a deploy transaction. So this function over here, or this script over here, is just a helper function. It's really got only one function in there, and you basically type in your testnet ADA into here. And then this query will allow you to see how much ADA you have that address. At least that's what I presume this function does. Now, I know you might be thinking there's a lot of different files involved. I guess there is. As I was going down the list, I was thinking some of these could certainly be in the same file. There's no need to have them in each function effectively being in a separate file. But I think for training purposes, it helps to separate them out so you can see, sort of bite-sized chunks of the code and know that certain things are independent of others. Okay, now down here we have the actual code that does the deploying of the smart contract and funding it. Every time you see found there, it means fund. So this is that script here. So get deploy and fund transaction.ts. Down here you'll see we can space there to put in your testnet address, so make sure you update that. And then what this is doing is then funding that for 10,000 Lovelaces, which I think is 10,000 ADA, or maybe 1,000 ADA. Oh, there's 1 million Lovelaces in an ADA, so 10 ADA I guess this comes to actually. So this is 10 ADA. So your script is being built, funded with 10 ADA, and then submitted. So this whole thing is a transaction that gets submitted and built here and then submitted onto the blockchain. And there's another space for your address here to watch out for. Again, a lot of this sort of scaffolding, I can't imagine will change much from project to project. You're essentially just submitting a transaction. Obviously, how much ADA you fund might change and so on. But by and large, I reckon a lot of this structure should be reusable. Okay, signs. Now that we have a transaction, we are just 2 steps away from it to being registered on chain. We want to sign it and submit it. So let's have a look down here. Okay, so I didn't quite understand this section, I'll admit. It says to sign a transaction, you'll need the private key of your address, which I presume means your testnet address. But the way that private key is derived seems to be coming from this over here. So it's taking the transaction, getting the CBOR hash of that transaction, and converting it into a string. That apparently is the private key of the address. So I didn't quite understand that link. If you have a better answer, then please leave a comment down below. But essentially that signature is what is then used to sign the contract. So we see that happening over here, and then the result of that is fed into sign.tx. And then this is where we're actually signing the transaction. And this is happening through the browser. So I think when I run this, it should pop open the browser and get me to confirm this transaction. Okay, now that we've got all those files set up, we can now update our actual index.ts file. So what's happening here? We're first of all importing Koios from the off-chain folder. We're then calling the get deploy and found transaction that we just looked at further above, up all the way up here, which is our main transaction that's building or deploying the smart contract. Sign with server, I think, is a function that comes from Koios. So we're then giving it the transaction. So, okay, we've built out, or prepare the transaction for you. It's all contained here. Go ahead and submit that now. So we load it into here. And then we actually call the submit function and wait for that to get completed. So at the end of these steps, we now have a smart contract running on chain, in this case a testnet, that has been funded and has our logic that we define for how to access the funding in that contract built into it. And we needed to use off-chain code to help us submit that onto the chain. So that's all that work that went on there. Finally, now that that contract's up there for anyone to use, we come onto the code for actually using that contract. So this last section shouldn't take as long. But this is the code that typically would be baked into, let's say, your DEX sort of browser or whichever website you use to interact with a smart contract. The key thing about the off-chain code such as this is it will be running on a server somewhere. It'll be centralized. It'll be running on, say, a Sunday swap server or a MinSwap server, etc., etc. So just to make that distinction between off-chain code, which is running on a server in a traditional way, and on-chain code, which is on the blockchain and it has that validator logic that we talked about. Okay, so using the contract, the last step is to build a new transaction that will allow us to spend the funds that we sent to the contract. So let's have a quick look here. We interrupt this broadcast to give you a quick overview of UTXO and script addresses. I thought it would be very helpful to give you a visual overview here before we get too far into the next bit of the tutorial, just because this will really help you with the understanding. So this isn't a Plu-Ts specific thing. This is a Cardano specific thing that I'm going to take you through, which will then help make sense of the Plu-Ts tutorial. And it took a lot of back and forth between myself and asking questions to the founder of Plu-Ts to figure all this stuff out. It's different to what I thought and how I thought things worked based on my prior understanding. Okay, so when you create a script and you hash it up, as we said earlier, that hash is effectively the script address. That script address is the same as any other Cardano address, just like your own wallet where you can hold ADA in there and hold tokens in there. Your script address can also hold effectively UTXOs in it, which is what ADA essentially is pieces of UTXOs. So your script address is just like any other address, and it can hold one or more UTXOs in it. And one thing that happens when you publish your script online is that in addition to having that address will hold a special token, a special UTXO known as the reference script. In other words, it's just another UTXO like any other, but the data contained within it is actually the script that generated that script, the script address. And that way, anyone that needs to look up the actual validator logic, the logic that we defined earlier, can go to that reference script UTXO to get the script logic. It doesn't have to be shared between people on some other server somewhere. It is on the blockchain as a UTXO. And you can then confirm that that reference script is correct. It relates to the script address that you're seeing it in, because of the fact that if you hash the reference script, you should get back to the same script address. So that's one way of knowing. What else? Oh, so each of these UTXOs, they can contain data, the datum. When a script is receiving UTXOs, when UTXOs coming in to the script address, it doesn't do any validation checks. It will accept anything that comes into it. It doesn't care. It's only when any of these UTXOs try and escape, or you try and withdraw the UTXOs, does the validator logic of the script kick into action. And that's the point where the datum, the data stored within the UTXO, will be looked at, and it'll be put, validated against the script logic and made use of there. So just want to put that picture in your head before we continue. Hopefully that made sense, and hopefully the next step of what I'm going to talk about will also make sense. Actually, that model I just talked about with that special UTXO that holds the script, that all came about through SIP33 reference script. So highly recommend reading that. Gives you a better understanding of the rationale behind it and how it works. So yeah, do have a read of that. Okay, armed with that better understanding of what a script address is, let's just go back a few steps to when we deployed our script to the blockchain. And I kind of glossed over this earlier, but let's just go back over this. You'll see there's actually two amounts for 10 ADA. It's actually unfortunate that there is the exact same amount, as that could cause confusion. They're two different things. This is the output which holds the reference script, that special token that I just showed in the diagram. When reference scripts are stored on the blockchain, you have to have a certain minimum amount of ADA attached to them in order for it to be allowed. And that's actually what this SIP talks about. And the rationale for that is that way, the larger the script that you're storing on chain, the more of a minimum ADA you have to pay. And that way, people can't just spam the blockchain and have ginormous scripts on there. They'd have to pay the equivalent fee. That's a rationale there. So that's why you have to have some minimum Lovelaces. So here we're putting 10 ADA in just to make sure that this reference script, sort of UTXO, is okay. And then separately, here's where we're actually funding the contract. We're putting in an additional UTXO, like the blue UTXO in the chart. We're making that 10 ADA as well. So actually, I think for training purposes, it would have been better if this was, I don't know, 20 UTXO or something. But yeah, so I just want to point those two out, because now let's go down to the using the contract section. Now, the tutorial takes a bottoms-up approach where it explains the inner workings first and then works its way out. I'm actually going to take the opposite approach. I'm going to start off looking at the final thing and work my way backwards. And I think you'll find it makes more sense doing it that way. So here we have the index.ts file. This is the exact same index.ts file that we ran earlier that actually created our script and deployed it to the blockchain. But now in that same file, we're also including code that uses that contract that we deployed, which I don't think that would be reality. I think in a production system, obviously, this code would be completely separate from this code. You might deploy your smart contract on day one, and then minutes, hours, days, or weeks later, you might then use that contract and run this code. But for purposes of a tutorial, I guess it was easier to have it in one file because you could reuse the TX object here, as we do. But I think I would like to see more of a production version of this where these two are separated out. But in any case, let's go through this. What this section here is doing is it's constructing the reference UTXO and then submitting that with the transaction. What do I mean by constructing the reference UTXO? So literally, I mean that special token that we just looked at. That special token that contains the script. We need to provide that token when we construct a spend transaction. But rather than going back to the blockchain to retrieve it, because we had all the information to hand, we're able to reconstruct it here. So it would be good to see a production version of this code where you don't have all this information to hand and you have to somehow obtain the reference UTXO from blockchain first. But in any case, once you've got your reference UTXO object, you can then pass that into this function, which we will look at in just a second, which generates your transaction. That transaction is then signed and then submitted using the same functions that we saw earlier. And then you got various sort of logging happening there. Okay, so now let's look at the function that generates that transaction. So get spend polite tx, so you see here it's taking in our reference UTXO. It's bringing in some helper functions over here. And then over here, it is retrieving the UTXO that we used to fund the contract with earlier. So this would represent the blue UTXO in my diagram. So it uses this function here from Koios to get back that UTXO. And this entire UTXO is now going to be what is spent, what is retrieved. You can't, take half of that UTXO. All UTXOs have a certain amount of ADA on them, and you have to consume the entire UTXO. And if that transaction that we ran to submit the contract to the blockchain with this UTXO hasn't settled on the blockchain yet, it will come back as undefined, and we can say, oopsies, are you sure your transaction has had enough time to get to the blockchain? So a little bit of error checking there. But assuming that's okay, then we get to actually build the transaction. So we provide our inputs here. This is the UTXO that we want to consume. We can't, only take part of it. We take the entire UTXO. And then here's the reference script as well that is going to be used to validate the transaction. So you see the my reference UTXO object here. You see datum saying inline. This is also part of the recent SIP changes. So prior to recent, I say recent, a few months ago now, prior to those changes, you had to provide the actual data that had been used when that script was constructed. And then that data would get hashed up and compared to the hash of that same data that was kept on chain. Or to put it differently, previously the data itself was never stored on chain. It was always a hash that was stored on chain. That way, that's why whoever was constructing this transaction that we're looking at here, the onus was on them to provide the data that was used, and then the stake pool operator or whoever validates this, they would have computed the hash from that and confirmed that this data is what was stored on chain, and therefore it's okay to use this data. That's how it would have worked. The newer method allows for the actual data to be stored on chain, not the hash, nothing fancy, nothing clever. The raw data can be stored on chain. That means you don't have to do any fancy converting to a hash, comparing hashes and confirming, yep, we're good to go. So in that case, if that's how your script was set up using the newer method, you just put inline in this variable to say, I'm not sending you the data, you already have it in the unhashed format. You can just go and look it up yourself. But we have to have this variable in there because there's obviously prior older transactions which may not be using this, in which case you do have to provide the actual datum that was used when constructing the script. Hopefully that all made sense. And then finally you got your redeemer here, which is that message that the validator script is expecting, and it says hello Plu-Ts there. So all of that is going to be used to validate your request, and if it goes through, then that UTXO that holds the ADA will then be returned back to this change address down here. I think, and there's a lot of section here for collateral as well. So I guess I don't know this one as well, but essentially whenever you carry out a transaction on Cardano, you need to have some collateral to allow the transaction to carry out. And it looks like that this function here must be retrieving this from your wallet somehow. But what I was going to say was it'd be good to see a version of this tutorial where actually you get to say, I don't want, I want to actually only bring back half of the amount that was in this UTXO, and the other half I want to keep in the script. Because as I said, the entire UTXO has to get spent, even in that scenario. If you only want to take half of the amount out, you're still going to be using up the entire UTXO, but in that case, the output would be a new UTXO that goes back into the script, and a UTXO that comes back to you. And I think actually that would be a good improvement to this, to see that in action as a step up from what we have right now. Okay, so I think that's it. Then after that, as we said, we sign and submit. I'm not going to go through and run it all myself right now, but hopefully when you run it, you get this message at the end, and then you can go and check your transaction on Cardano Scan. So Cardano Scan allows you to see the pre-production network in addition to the main network as well. Finally, after all of that is done, please return the ADA back into the faucet that we got it from. It's just test data, it's not worth anything, but there is a limited supply. And so whenever developers are testing, they borrow it from here, play around with it, and then when they're done with it, they return it so that that limited supply never runs out. So it's very good practice to do that. And you can return it just by manually sending it to this address. You don't need to run the code. You can just do a manual transaction through your wallet. Okay, that's it. I hope you found that useful. I hope you found that motivational. I certainly have learned a lot from doing this. There's a lot of changes there that I hadn't really appreciated since the days that I did Plu-Ts Pioneer. So it's definitely been challenging for me. And it may have seemed lengthy at time for a Hello World tutorial, but really this is much more than a Hello World tutorial. This is showing you the full sort of set of pieces that goes into a transaction and make sure that you understand each of the different bits there, rather than literally just printing out Hello World or submitting Hello World, which I think we did right at the very beginning anyway. If you like this video, please give me a thumbs up down below, leave a comment, and follow me along on Twitter if you want to keep up to date on my daily ramblings. Other than that, I hope you all have a great day.